In this demonstration, I would like to show you how to use the pathway wizards and also use the pathway element individual tools to build your AOP diagram. We are also going to look at the bottom of the screen toward the context-sensitive help to see how it can guide us in this process. So let's go to Effectopedia. Before you start your AOP, you have to note that if I click here on Contribute Adverse Outcome Pathways, it will be created in the selected data source. In this case, this will be test database. But if I choose a different data source, then this AOP will be created in the local memory in this case. It uses, when you create a new AOP in a specific data source, it uses already existing elements. So we are going to use the test database because local memory have nothing in it. So let's start our new AOP. The new AOP that Effectopedia created for us is a blank. It doesn't have any key events or anything else. So we can start building the AOP by using some of the AOP wizards. AOP wizards are actually helpful to create a linear AOPs just by adding two elements like the chemical initiator and the adverse outcome. And also please note at the bottom of the screen that when I move my cursor, the context-sensitive help show us what are the sequence of actions that we need to follow in order to use the tool. So let's left click on the pathway wizard mode and go to molecular level at both male and female and choose the place where we want to put our chemical initiator. So if I single click here, the new chemical initiator will be added. Then you note that again at the bottom that now the pathway wizard advises to add the adverse outcome. So if I go to individual level again for both male and female and single click, you can see the sequence of key events is created on each level of biological organization. And in case we don't have information for some of the levels, we can select edit mode, click on the element we want to delete and click delete on the keyboard. So with this, our linear pathway has been created, and we can also start adding additional elements using the individual tools. The individual tools are C for chemical initiators, L for links. This is the general tool for key events, and this is the test tool. So let's choose first the chemical tool and add one more additional chemical to our AOP. Depending on where you have this highlighted blue area, this is where our new element will appear. And if there is not enough space in the current segment, it will be automatically expanded to contain our new element. So let's click just below our existing chemical structure, and it will expand the segment and put a new chemical structure. When you are in this mode, you can see that you can create only chemicals or initiators in general. If I hold my mouse button on top of the element and we have this blue highlighting rectangle surrounding the element, then I also can change the type of the element I'm creating. But it only creates initiators. Also it doesn't allow me to create initiators where they don't belong, like on a higher level of biological organization. It only allows me to create chemical initiators on molecular level. Let's say we made an error with those two chemical initiators and we don't want them. I can switch to edit mode, left click, and drag a rectangle that will select all my unwanted elements, and then I can click Ctrl Del to remove those elements from the AOP. Um, if those elements contained any information, they will be just dissociated with the AOP, not removed permanently, because some other AOP might be using it. So let's now go and link our chemical structure that we have created to the molecular initiating event using the link tool. Again, pay attention to the bottom of the screen where we have add link now, and we have several options that we can use to create a new link. We can first place the link and then select the upstream and downstream element, or we can first select one of the elements, then we can place the link and select the other. Let's go with the sequence. So I'm selecting the element by highlighting it. Again, the whole element should be surrounded by a blue shaded rectangle. So if I single click here, you can see that now the context sensitive help changed to add a link. So we need to find the place where we can put the link, and it's better to be between the two elements that we are going to link. So I can click here and new link will be added. And now the context sensitive help change to select downstream element by single left click. So again, I need to single left click on the element while it is selected with this blue rectangle, and it's highlighted in red. So if I single click here, our link is now created. Let's also create a new key event on organ level, for example, for just males. So I single click here in the segment and we have a new key event. Let's again use the link tool to link this new key event to the pathway. So this time I will use different strategies. So first place the link and then select the two elements we want to link. So if you choose to first to select downstream element and then upstream element, this doesn't change the direction of the link. It is always from lower levels of a logical organization to higher. And finally, let's add some tests that will be used for measuring key events or molecular initiating events. To do that, you just need to select your key event that you want to associate the test with. Click once and then choose the place where you want to put the new test, and the new test is created. The various type of tests are in chemical. If I single left click, then it will become in vitro test method. Again, single click ex vivo, in vivo, and in silico. All of those test methods have slightly different properties and interface, so you can use them as you need. Let's add another test, this time in chemical, and I was using the other strategy to add a test. First place the test and then select where the test response mapping will be placed, and finally select the key event which we are testing. So now that we have created the structure of the AOP, and you can see all of the tables that are related to this AOP were created automatically for us. So we have here the molecular initiating event, the several key events we have created, and the adverse outcome. Let's go and start naming the components. So we are going to start with the chemical structure. If I double click on the chemical structure, Effectopedia will show me dialog which shows me existing chemicals that I can use and add to my AOP. but I can also choose to define new. So here is the chemical name that will appear in the box. Let's use something that we can use as smiles, and I'm copying this smiles and pasting it here. It is supposed to be named, but I also coincides with the smiles. So if I hit enter, this diagram is generated corresponding to the smiles. You can also enter the cast number and any other information. The cast number is automatically stripped from all the character symbols that are non-numbers. Also, please note that this structure diagram is also represented here as the main constituent of the pure substance. So Effectopedia allows you to define multiple substances that might have impurities and basically represent a physical entity that you can source from a chemical supplier, and you can add impurities and other constituents by just clicking here and then add additional chemicals. We're going to use for now just the pure substance. Let's go to view and maybe change our other chemical. So again, I'm going to choose simple name, use it as a smiles, and okay, we can go back. So we can do the same with all the elements, and if I choose define new everywhere, I will create completely new AOP without using any of the existing knowledge. And we can do that also by following those links. So if I double click on the title of the downstream key event, it is loaded again in the center of the editor, so I can change the title. This feature will be disabled in the future, so we have always this dialog that lets you choose the existing key events, but currently it is still enabled, and it is easy for demonstration. So I'm just going through all elements of the pathway and giving them a name. Okay, let's go back to the view. And now you can see that all elements have names. So this is MIE1, key event 1 leads to key event 2. We can also name our tests, and in this case this is in silico test, but there are some existing in silico tests as well. So this is just so Effectopedia shows us the existing ones that we can associate with the pathway, but we are going to use just a new one. So again, define new. Okay, so if I click somewhere outside of any selected key event or element of the pathway, you can see on the right the pathway description is loaded, and it now contains our names. So let's go and call this AOP test AOP1. You can also see that all elements, if I double click on them, and look at the associated pathways. We have this test AUP1 associated with the element. Um, so we have two options now. We can either save all we have done in a local file, or we can publish it to the centralized database. So let's choose save. By default, the type of the file that is created is an XML file which is compressed with the extension AUPZ. And if you want to have non-compressed file, you can choose the AUP extension. You can also save only the image of the diagram as SVG or PNG. So let's go ahead and save this file on the desktop as test. So our file has been created, and let's close Effectopedia and start a new session, pretending that we come the next day to see if our file will be loaded. So let's start a fresh new copy of Effectopedia. And open our previously saved new model, new AOP. So one interesting thing that it might not be obvious is that this file that I'm currently opening contains not only our new AOP, but the whole database that was selected as originally as a data source. So you can also see this by the revision number here. So this is revision number 12, and our original test database is still at revision number 11. This is done so we can actually work offline and have all the key events from the original test database. And once we are ready with all the changes, we can publish our new AUPs at the centralized database. So let's go and explore our test file just to show you that it actually contains all the AOPs, including in the last page our new test AOP. Also by default, as you note, when I opened this file, it did load the lastly modified AOP automatically in the viewer, but this doesn't mean that it contains only this AOP again. It contains all the rest of the AOPs. So if I click on another one, you can see it. Now I will be happy to answer any questions that you might have. So we had the following three questions during the live sessions of the webinar. How controversial data could be represented in the AUP diagram, and how the call for significance could be made in those cases. In Effectopedia, as in AUP Wiki, we have those fields to specify, for example, for key event relationship, the weight of evidence, and we can summarize it to just one word, which is weak, moderate, or strong. And this has proven to be very difficult for people to assign and make the call. And for that reason, we believe that it will be much more easier to just supply the evidences and let the experts who are evaluating the AUP to make their own judgment call. And in Effectopedia, you can actually supply multiple response curves. And for example, one of the curves can be based on experimental data, and you can see how it is derived, and the other one could be based on a different set of experimental data and might be also contradicting the first one. And by just making all the data transparently explained, how the experiment was performed and what was done in both cases will make much more easier and substantiated evaluation of the weight of evidences, which one is really more important, or if they're indeed controversial, then just think about maybe redefining the key events because they are not necessarily causally connected. Also, another component of weight of evidences is the temporal concordance, which in Effectopedia you can actually supply in with data as well. So you can show, for example, how binding to the ER occurs in time, and if it indeed is followed by the ER transcription factors, or how those two key events occur in time in general. So let's go to the second question, which is there any undo button? Unfortunately, there is not, and hopefully we can introduce it very soon because this is a frequently requested feature for Effectopedia. So the last question is, are object, process, action, context, control vocabularies from the wiki are going to be available in Effectopedia? And the answer is yes. We're going to synchronize the ontologies in both systems completely. So we have exactly the same ontologies used across the whole knowledge base. Currently, Effectopedia has some controlled vocabularies, and this is the biological context, or the ontologies are represented in this section in Effectopedia called context. And currently, only part of those are controlled by vocabularies, but this list is expandable. So whenever we find some applicable ontology that is relevant to describing the key event in this case, it could be added to the list. And in the same way, the wiki process and object keywords or elements from ontologies can be added.